Today in Algebra 1 we learned about relations and functions. We started with some vocabulary. The first word is relation. A relation is a set of ordered pairs. Think of this like a relationship. It requires two people. It's a set. Relation is a set of ordered pairs. The domain is the x values. The range is the y values. Okay? If you look at that, think of it alphabetically. It will be a good way to memorize that. D comes before R, X comes before Y. Domain is the X values, range is the Y values. You will need to memorize that. That will be very important for the rest of your math life. The last word is function. And a function is a relation that pairs each domain value with exactly one range value. So they match up. X's do not repeat. That's very important. We'll talk a little bit more about that tomorrow. If I split this box into two categories, the first one I want to put all the things that have to do with X. So that's domain, X, input, and independent. Remember, input and independent we learned more about yesterday. In the second box, then, the words that would go together would be range, Y, output, and dependent. And I can use these words interchangeably, so I need to know which ones go with which. So I need you to know that so that you know what I'm talking about when I use those words. We have several different examples of things we need to learn how to do today. Example 1 says, express the relation for the track meet scores. 110, 28, 36, and 44. And it wants me to express as a table, a graph, and a map. I'm going to start by making a table. In my first column, I want my X values, which would be the place I got in the meet, like first place, second place, third place, or fourth place. Taking that from each one of these X values. The second column would be my Y values, and that would be the number of points my team earned as a result of what place I got in each event. For first place, they got 10 points. For second place, 8 points. For third place, 6 points. And for fourth place, 4 points. That's an example of a table. Let's look at an example of a graph. Since you can't get a negative place, I'm not going to do a negative over here, and you can't get negative points, I'm not going to do negative for the y-axis either. If I was given those, I could do my graph the other way. My possible x values are 1, 2, 3, and 4, and those are all of the places I could get. My points go all the way up to 10. I'm going to go by 2's on this y-axis. That's the number of points my team earned. I'm just representing this material another way. If I graph that, I have 1, 10, 2, 8, 3, 6, and 4, 4. And I don't connect them because I can't get 1.5 place, right? So that would be an example of a discrete graph. We've already talked a little bit about that. The last representation is a map, which is like these two ovals. In the first one, I'm going to write all of my x values, 1, 2, 3, and 4. In the second one, I'm going to write all of my y values, and I'm going to write them in order from least to greatest. Okay, let's just get in the habit of doing that. Then I'm going to pair up my matches. 1 goes to 10, 2 goes to 8, 3 goes to 6, and 4 goes to 4. And that would be a map representation. Let's look at some examples of how to find the given domain and range. If I look at example 2, my domain, remember we said domain was all of our x values, that would be like 1, 2, 5, and 6. Our range then would be all of our y values. Our possible y values are -4, -1, and 0. And that's our domain and range. Let's try for example 3 on a continuous graph. My domain, again, is my x values. If I look at my x-axis, I have something going on from 1 all the way into 2. So I have from 1 to 2. Notice I put the line under here. You'll have to remember that from inequalities. It's a closed circle, so I do a closed line under my inequality sign. If I look at the range, that's my possible y values. It starts, my lowest one is at 1, and the y values are what's in between here. And it goes all the way to 4. That's my highest one. The reason I wrote this way and the other one the other way is because on this one it could be 1.2, 1.3, 1.4. On this one it's exactly 1, exactly 2. So there's a little bit of contrast there in the two ways we could write from a discrete graph to a continuous. The last thing we want to do on examples 4 and 5 is to give the domain a range again and tell whether or not it is a function. On example 4, the domain, again, is the x values. It always is. Those are 68, 75, and 125 are my possible domain values. My possible range values are 2 and 3. Notice I did not write the 2 twice because I don't need to do that. It's already accounted for here. The possible range values that I could get, or possible y values, are 2 and 3. This one is a function because the x's do not repeat. They're each separate and different. So yes, this one is a function because nothing repeats. Let's look at example 5. Start with finding the domain and range. If I look at the domain, I have 7, 9, 12, and 15. This one would be an example of a map. My range is -7, -1, and 0. Those are my possible y values. And then I need to say, is it a function or not? Notice here that 7 goes to -1 and to 0. So this one is not a function because 7 is shared by 2 different ones. So they would not have a unique or different x value. And since the x repeats, the answer is no, this is not a function. Your assignment that goes with this is A2. It's page 239, and it's numbers 1 to 12. Good luck. Let me know if you have questions.